Hello everyone. Today let's look at how to implement our own LRU cache in Leetcode. Let me just walk you through this example to better understand what an LRU cache does. So this LRU cache, when initialized with the constructor, it's given a capacity. For this example, let's take it to be 2. And when you do a cache dot put of 1.1 for a key of 1, and you are putting a value 1. So let's try putting another value. Cache dot put 2 of 2 will put the key 2 as with the value 2. So now we have two elements in our cache, which is the same as our capacity. Okay, so now when you do cache dot get of 1, you should return 1, since for this key of 1 we have put the value as 1. Okay, but now any subsequent put operation will need to evict something, because our capacity is 2 and we already have two elements. So to put any new element into our cache, we should evict it. And in LRU cache, this eviction is based on least recently used, meaning whichever key is the least recently used will be evicted from the cache if we have reached the capacity. So since we have done cache dot get of 1, 1 is the 1 has been recently used, and so that makes the key 2 to be the least recently used. So this put operation will evict key 2 and put this element 3. So subsequent cache dot get of 2, since this key is no longer present as it's evicted, should return -1. And if you push cache dot put of 4 of 4, that should evict this key of 1, because that is the least recently used for this case. And then the following cache dot get of 1 will return -1, since it's no longer there in the cache. And cache dot get of 3 and 4 should return their corresponding values. So let's try to code it up. So I'm going to use C++ language to code this up. Okay, before we actually write the code, let's think about this problem. So it's also mentioned in this that can we do this both the put and get operation with order 1 complexity. So the get operation for a cache is LRU cache is very similar to that of a normal hash map. So you have some key and you have to get a value. For order 1 lookup, you can hash all the keys and get the corresponding values. But since we need to evict some values based on whether we have reached the capacity or not, this cannot be done by a simple hash map. For that, we have to know which is the least recently used element. So we need to keep some sort of an ordering. So let's try doing this. Let's have two data structures. One is going to be a linked list for our ordering to determine which is the least recently used key, and we are going to have a simple hash map for order 1 lookup for a key. Okay, so we are going to combine these two data structure. And how is that going to give us? So hash map, as it's trivial, will give order 1 lookup for get operation. And so how can we evict the elements using this both the combination of hash map and linked list? Let's have something like this. So this hash map is going to have the key same as that of our normal key, and in case of a value, it has a pointer to our linked list. Okay, by the way, this is a doubly linked list. Okay, pointer to a doubly linked list. And so when you actually get a get operation, you're going to get or a put operation, we are going to rearrange the linked list such that the ordering of the linked list is such that the first element in the linked list is going to be the recently used element, and the last element will be the least recently used. Means that ordering is going to be preserved. So whenever you reach the cache capacity, you have to remove the element from the end of linked list. Okay, so that is going to give us order 1 put also. Okay, now let's try to code this up. So here, since we need a linked list, I'm going to include this list header, which is going to give us this templated list that we can use for any doubly linked operations, doubly linked list operation. So let me just make a list of, okay, now what should be the each node in this doubly linked list? We have a key and a value to be stored in this doubly linked list. So I'm going to have a pair of int of int, and I'm going to call it DLL, which means a doubly linked list. Okay, now we also need a hash map. So unordered map of int of, now we know that the first hash map of the first is our key, which is int, and then pointer to our doubly linked list. So we need to have an pointer, which is basically an iterator. Okay, so that is going to be our map. Okay, now during the, we also need an integer called capacity to store what is our capacity. So in our constructor, let's use the initializer list to populate the capacity, and we are going to do dll.clear and mp.clear to clear our data structures. Okay, now we have our get operation. So in case of get, what we should do, first we should check if that value is there, if that key is there in our hash map. So that's is not equal to mp.end, means that this key is present. In that case, we have to do something, and else we know we can readily return -1. You don't need an else here, you can just return -1. Okay, so if the key is present, we need to actually manipulate our doubly linked list, put it in the front of the linked list, and return the value for that key. So we have our iterator itr equal to, sorry, a list of pair of intent iterator equal to mp of key. Okay, and we have this, we need to actually have the value, int value is equal to iterator of second. Okay, we are going to return this value, but before that we should rearrange our linked list. So I'm going to erase that, I'm going to erase this node from the linked list first, and then I'm going to push it to the front of linked list, since this is the recently accessed element. Okay, push front, make another pair of key and value. That should work. And we need to also update our key to our dll dot begin. This is the front of linked list. Okay, and now we can readily return our value. Okay, that's the get operation. Now for put, what we have to do. Okay, first let's check if the same check, if that element is present within the in our hash map currently or not. If that's present, put is basically an update operation. So what we have is we are going to have a similar logic to get. So we have this iterator. First we are going to get this iterator to get the value for this. First we are going to get this iterator, and then we could just readily erase this element from our linked list. And what we can do is dll dot again push front of the iterator, dll dot push front of make pair key comma new value that we have. Also we need to update our mp of key is equal to dll dot begin. Okay, so that's what we are going to do in case of that key is present or not. If not, then we need to check whether the number of elements currently in our LRU is equal to our capacity or not. So if it is, then we need to do eviction. Okay, so how we are going to do eviction? So this is why using this list is going to be extremely helpful. The list also gives us another reverse iterator, which is going to give us the element which is in the behind. So r begin should give us the element which is in the behind, and so we are going to get its value. Int value is equal to dll, sorry, this is a reverse iterator hyphen this is going to be our value, sorry, this is going to be our key. I'm going to get the key first, and then we need to do eviction. So I can do mp dot erase of this key. Also what I can do before that, let me erase it from the linked list itself. Erase of mp of key is going to delete that element from our w linked list, and this is going to delete. So we have rightly evicted the last element. Now let's try this. Let us now add this new key. So that's going to be the same logic as earlier. We are going to push this new key and its value, and otherwise we are going to do this. So this we should do if we have not reached our capacity also, we can do this readily. So this code is redundant, so I can just put it outside the else itself, and we can remove this, and I can remove this, and yeah, this should pretty much work. Let's try running it. Right, so let's try submitting it. Yeah, so that works, guys. Hope you guys enjoyed this one. See you on the next one.